Okay, so for today, we focus on data preparation, part of any data mining based project. So you need to go to your Moodle and download Descriptive Analysis Jupyter Notebook, also Titanic underline alt.csv. Please download them and go to your Databricks account, make a new cluster, and upload both of these CSV file and also Jupyter Notebook. I give you 5 minutes to do that. I know it might take a little bit more time. So I'm waiting for you guys. Please do it in 5 minutes, and then we keep continuing from there.
Excuse me, Professor. So, like, which two CSV files should be uploaded? One is Titanic Alt, and the other one is
Just one.
oh, just
Just
one.
Titanic underline alt.csv. Also, Descriptive Analysis Jupyter Notebook. The one that I highlighted. It's on your Week 10 over model.
Hi, Hamid.
Yes.
Where should we submit a project proposal?
If you look at your model, it's one of your assignments. Let me check. Assignment 6.
Oh, I thought this one. Okay.
Okay, let me change assignment 6 to parentheses project delivery 1. Okay, please upload that CSV file and also Jupyter Notebook over your Databricks platform. So you have 5 minutes to do that. Otherwise, it's hard for you to follow me. Okay, let's open the CSV file that I shared with you. This is a Titanic data frame or table, which I altered for today practice. I made it more challenging to put some typical problems that you might see in other projects. By the way, through Pi Spark or even Hadoop ecosystem, you usually work with a very large data set that you don't have the privilege to download as a CSV. But here as a practice, we do that. So as you see, we have so many innate. Some of them are for survived, which is our dependent variable. Some of them for independent variables. We have some values like 888. Also for age. Let's see. I think I just saw the 888 for your age. There is no people with the age of 888 years. So that should be something. Also, if you look at your cities, I added new variables like L for London, B for Beijing, and D for Delhi. So like these are for Delhi, and B4 is Beijing, like these ones. And instead of embarked, which is in the original data set, we have city, which means the original city, and also BMI. Like BMI of a passenger, if their BMI is too high, then it's hard for them to escape. Or if their BMI is too low, maybe their body doesn't have enough fat for tolerating the cold. So anyway, there's some differences. So anyway, still you can have some options to download your file as a CSV, even if you work in the real Hadoop ecosystem. You can randomly select some rows. If you do a good sampling with that random sample, you still can download it and is affordable to check by your system. So for now, let's do also check some random functions in Pi Spark environment that you might use it later. For sure, for now we don't need to use them, but later, if you want to get a sample of the database that you might work on your local system, it's better to do sampling to get a general idea. So anyway, let's go to the Jupyter Notebook. So here, from a typical project that is defined by KSTM standard, my focus is in data preparation part. As you see, is a cyclical process. You might do all this stuff from understanding the problem through business understanding, data understanding through data dictionary, data preparation, modeling. And when you go to evaluation, maybe sometimes your model is not good. You have to go back, change some part of data preparation, maybe, and then do the evaluation, just go back and forth. Maybe you change some of the modeling sections and to see if you have a better performance. So there's a cycle. In one of our sessions, I've talked about pipelines. So if you want to do different cycles, and in each cycle maybe use different approaches or different settings, pipeline helps you to organize it. So later, people, if you check your pipeline, they can see the steps that you follow. It's not necessary, but it just helps you to organize your coding, especially in the machine learning project that you need to go back and forth a lot. So having a pipeline is really a good practice. So anyway, so let me show you how to work with the random functions. From Pi Spark Sql, import rand and randn. Rand is for uniform random number, and randn for creating normal data from normal random data. So with the range, first of all, in Spark SQL data frame, the most important column is ID column, which is a unique identifier for each row. So let's see how I create them. So I'm just saying that from SQL context, add range 0 and 9, 0 to 9, and assigning data frame 1. And this command just make a Spark data frame with the ID column, which selected automatically. I didn't define ID name here. And so it's an empty data frame with 9 observations. Now I add 2 more columns that are created randomly. So let's see. I'm just saying that first, create that empty data frame from 0 to 9. Select the ID column. So ID is here. Also, using the seed number 110, make some uniformly that distributed random number. So by the way, if you forgot the uniform distribution, normal distribution, please Google it, and it's a very easy content. So from your statistic class. So I'm just saying that create uniformly distributed numbers as a column, and just put their names uniform. So the name of uniform is arbitrary. You can put any name there, but since it's, I created uniformly distributed random numbers, I just said the column name is uniform. Again, I'm using rand n. Now I create normal distributed random numbers, and with the alias, I just saying the column name. Oh, the column name is normal. Also remember, sometimes you use functions from different packages. Some packages work very well in a Spark environment, like pandas and NumPy. Some of them, like sklearn, is not very compatible with the Spark yet. Maybe in future they make it more compatible. But anyway, so with 2 pandas, you can convert it to the panda format, and now you can use the functions that are available in pandas package through a Spark environment. So let's look at them. With dot show method, I see the randomly created data frame. So it has ID, uniform, which has uniformly distributed numbers, and also normal distribution. So what can you do? So basically, the reason I'm telling you these functions, maybe later you have a very large data set. You cannot just download whole, or maybe it has 2 million rows, so you cannot download it in your system. What can you do? Maybe you make a new column and just say from uniform column, just select everything more than 0.8. So it's uniformly distributed from 0 to 1. More than 0.8 means 20% of my data. More than 0.85 means 15% of my data. Or from your normal distribution, here you know how to convert the standard normal numbers to associated probability. Maybe with those standard numbers, you just select 3% of your data, or like 2% of data. So you can use these randomly created numbers for selecting some certain rows. Then later I show you some functions. So I think uniform distribution might be better, but basically you can use either of them for randomly selecting a very small portion of your data. So you can download on your system, and it's much more easier to process them. If you have, let's say, 2 million records of your data, maybe you can download 50,000, and still it's easy to open 50,000 observation in your system. And like the CSV file that I just opened, you can just open it and get some insights from your data. You might remember as a review, we had the describe method over Pi Spark Sql Pi Spark Sql data frame. So I'm just checking at the descriptive statistics of uniform and normal. You can see count, mean, standard deviation, mean, max. Later, I use describe method for getting some insights from my data. Okay, let's go to the real deal. Any questions so far? Okay, so let us skim through the next. Okay, one question. Oh, okay. So in next few block, I'm just I skim through them a little faster because we already had so many examples of it. But if you have questions, you can just ask me. So if you already uploaded the Titan.underline ALT CSV, you have it on your system. Let's look at the schema. You can see survive is an integer. It should intuitively should be a string because although it's 0 and 1, but 0, 1 doesn't mean anything. It just means two different groups. But since in the machine learning algorithm, all of the categorical variables should be converted to the numerical, either by one-hot encoding or label encoding, I'll just leave it as it is. But as a practice, we can convert P class because it's a class of the passenger. Maybe we can convert it to a string. And let's see one else. The remaining looks fine here. So anyway, here is the data dictionary. As you see, pretty much similar to previous one. Instead of embark, I have a city, which means origin city of passengers. B, Beijing, D, Delhi, C, Cherbourg, Q, Queenstown, S, Southampton, and L, London. Also, I said 888 means 888 means the value. If it's unknown, we assign 888. Maybe you can assume it as a null or empty cell. Also, we don't want to work with the ticket number or cabin number. Doesn't make sense. Maybe we can just exclude them and just focus on the variables that makes more sense. So here I define a schema and I convert some variables that doesn't make sense for me. For example, I change the P class, passenger class to a string, convert them. We look at the true schema right now. And with the show method, we just see a snapshot of my data. Okay, so far it was pretty much similar to what we reviewed in the previous classes, but anytime you have questions, just please ask either through your microphone or texting me. So similar to previous classes, we can do something. First of all, we need to convert 888 to null. As you see, for the categorical variable of P class, instead of 1, 2, 3, we have 3.0 or 888.0. So, but for numerical variable, they are 888. So what I'm doing here, I'm just saying that with the replace method, whenever you see 888, convert it to null or none. Whenever you see 880.0, through quotation means it's a categorical variable, convert it to null. I'm selecting the variables that makes more sense for me. And you might remember that we can do loop over all the columns, count them whenever they are null to see how many empty cells we have in each column. So with df count, we see how many rows we have. With df.columns, you can see how many columns. So as you see, we have 891 rows, 9 columns, and these are number of empty cells in each column. So as a question, what should I do with the nulls that I have under survived column? And survived is my dependent variable.
Delete row.
Yes, very good. What about P class?
Replace with mode, I think.
Yes. Or you can say, yeah, replace is right. Usually we say impute. What about age?
Mean or median.
Yeah, I mean, age, it's too many empty, like 180, but we have 891, so not too much. What about BMI? what should I do with the null under BMI?
Delete column?
Yes, drop it.
Yeah. So yes, whenever, first of all, when you have we have a very large data set, it's very good to find good reasons to get rid of some of the columns to make the computation easier. But you should have a good reason. Let me loop over this data frame. First of all, what you see here, I use .show method, so it means it's a data frame that I could apply this method. So let's do a loop over each column and divide them by 891 number of rows to see the proportion of empty in each cell, which I'm doing here. I'm doing a loop over the schema fields, and I'm just saying that get that name and the column and divide them, the value that you have there by the number of row, df.count is number of row, and round them with 4 digits. By the way, I'm dividing whole of the column, but since each column I have one number, I don't need to specify the row. I'm just saying that whatever you see in that column, divide by number of rows. So anyway, if you look at visa for survive, we have 1%, PKLS just 2%, BMI more than 95% or 96% empty. You still can impute it, and if you do feature selection, it won't be important, it will be kicked out. But again, for ease of calculations, you have a good reason to drop BMI. You can say almost all of the column is empty, so let's just get rid of it. But if it's 90% is empty, maybe it's better to still impute it. If it's more than 90%, I recommend to drop. Otherwise, just keep it and do imputation. So with drop, by the way, look at the round function. Round function here is a Spark SQL function. It creates column. So later I show another round function that give you the number, but here is a bit tricky. With the with column, use it with with column to create to just replace a column is a better term for that. So just later I explain further, but just keep in mind this round function is for Spark SQL package. Anyway, with drop, I drop BMI, and now these are my observations. Okay, so we got rid of BMI, so we need to do imputation for age because it's a numerical value. We do like by median. For sex, P class, and city, we impute by mode. So what I did here is similar to previous class, so let me just go fast. First of all, I'm using simple imputer function from sklearn. As I said, unfortunately, it's not completely compatible, but still you can use good function from that package. So what I'm doing, I'm just saying that for this function, my data frame should be converted to the pandas. So I convert it to pandas, make a deep copy over miswork, and using simple imputer, I impute with median. I make this object, and I'm doing imputation over from column 3 to 4, but 4 is not included, so it's just to imputation over column 3. So if you look at here, 0, 1, 2, and column 3 is H because it's a start from 0. And same for categorical variable. I pick 1 to 7 as the location of my categorical variable. And I use fill_na function here and impute with mode. And also, as you see, I'm just using drop_na method to just over survived column, just drop the observations, that has null as a dependent variable. And similar to previous one, I'm looping over columns and checking and counting number of null in each column. So now I have 0 null. So I got rid of all of my nulls. So far I just skimmed a little fast because we already had several examples before, but I give you a couple of minutes to look at the previous blocks. In case you have any questions, please ask me, and you have a few minutes, then I go to the next portion of today's session. Okay, let's continue the next section. So again, with the describe method, I can check the descriptive statistics of numerical variable, which is age, sibling, parent, children, and fail. So look at this summary statistics. Can anyone tell me any problems by just looking at this report? So you have now count, mean, standard deviation, mean, and max.
Age negative.
Which one?
Age.
Age. So what is the problem in the age?
Minimum age is negative.
Yeah, -7. So it means they will born 7 years after Titanic. So it might be some issues. Yeah, it doesn't make sense. What else? The other issues might be a little subjective. First of all, maybe 120 is too much old, but it still makes sense. Or number of sibling 8. You might find somebody with 8 siblings, or parent and children 10. It makes sense, but it seems outliers. Also, look at fair, 0. Maybe they are like, I mean, they didn't pay and just illegally boarded in the ship. Or 512. The mean is 33. Look at 512. It still makes sense. Maybe they are princes from a kingdom of European kingdom that they pay too much, but still far from your mean. Even for parent and children is 0.410, 0.58. Okay, what's your issue? Go ahead.
In pandas, when we use the .describe function, it gives the quartile as well, like 25%, 50%, 75%. But like this is not giving any particular reason that they don't give, or
yes, because I previously I talked about round function. This describe is over your Pi Spark Sql. This name is exactly the same as the pandas, but it's not the pandas method. It's a Pi Spark Sql method.
Okay.
So yeah, it might be challenging. So it's one of the reasons my focus is not teaching you functions, because there is so many packages, there is so many functions, they have so many subsections, and also there is similar functions in different packages. So what can you do for your project or future work? You can use some notebooks and just build on top of that. So you don't have to just make all of the function from scratch. For example, for your project, you can use the notebook that I just shared with the descriptive analysis, and just look at some parts, maybe as if it's applicable, all of them is applicable, maybe just change the file name and do the remaining. But probably you still can and should change the column names. Or maybe you want to add some parts on top of my notebook. So instead of just doing all of the blocks one by one, just search for the documentation of certain functions and just use them to add on top of it. So you don't need to invent the wheel. So you can use other wheels and to make your car. So, but really good question. Okay, so first of all, one way for sure we can drop the age who are negative. Doesn't make sense. Or maybe if it drops a quite bit large, maybe you just change negative to null and impute it. So as you see, there's different approaches. One approach is checking outliers and just get rid of outliers. But you might drop too much of outliers. Or maybe you have two groups of observations. Let's say, for example, for age, look at the mean is 29. Maybe you have two groups. One group is old people, more than 60. Another one, less, but majority are less than 40. So in that case, maybe if you get rid of outliers in age, siblings, parent, and fair, maybe you end up losing too much variables, too much observations. So one way, you can add new dummy variables. For example, let's say instead of get rid of very expensive fare tickets, maybe you can make a dummy variable for wealth with two groups of very rich with level of R and ordinary with the level of O. So let's say any fare more than 300, instead of dropping them, you make a new observation of R. In the new column of wealth, you put rich, expensive. Anything less than 300, you assign O, means ordinary. So different approaches. I mean, from now, instead of imputing negative ages, I drop them. Again, may not be a good approach. Also, I don't add new dummy variables. I drop outliers. But as I said, in your project, maybe up to now is same with your project. From now, instead of dropping outliers, maybe you add a new category to them. Or you can divide your data in two sections, one for very rich fares or for old people and young people, and you make two different models. One model for very old people or ordinary people, or very rich people or very ordinary people. So different approaches. I don't say which approach is better. The better approach has the better predictive performance. But as I already said, we have followed QSTM standard. So if your performance is not good, just go back. Maybe here I drop outliers and my prediction is not good. I go back, instead of dropping outlier of age, sibling, parents, and fair, I make new dummy variables. Like, for example, also, instead of dropping very old people, make a dummy variable of age cat with two groups of, let's say, elderly means more than 50, and younger means less than 50. So you do the same for all of the columns. But from now, I'm dropping age minus, any negative ages. And also, for all of the numerical values, I want to get rid of outliers. Let's see what happens. It might be really good, it may not. First of all, with filter method, I'm filtering every age is more than 0. So the remaining would be excluded. So negative won't be here. Also, with the approximate quartile method, you can get your quartiles. So basically, I make a new dictionary. My dictionary keys are Q1 and Q3. It stands for first and third quartile. I'm looping over all the columns. So DF is my data frame. I'm looping over those names. And I'm getting the first quartile means 25% of my data, and third quartile means 75%. And just save them in the new data dictionary with the keys as the column names, Q1 first quartile, Q3 third quartile. By the way, if you forgot how to calculate outliers and what those quantile means, please just review them, Google them, review them. There's an easy formula. Or check your notes in the SEO statistics class. They're very easy concepts, but it's out of context for this class, so I don't review them here. But basically, for finding outliers, we make first and third quartile. The distance or differences between these two quartiles is IQR. Then for each variable, we make a lower bound, which means first quartiles minus 1 point times IQR, upper bound, third quartile plus IQR times 1.5. Anything more than lower, upper bound or less than lower bound would be your outlier. Again, I make a new dictionary. In this dictionary, for each column name, I have first quartile, Q1, third quartile, lower bound, and upper bound. So look at sibling. Can anyone tell me number of sibling less than 1.5? What does it mean? Is it right? If it's right, how could you use it? Or how you interpret it in the model? So by the way, when you do descriptive analysis, don't just use function and leave as it is. So, and also you work as an analyst, every number should make sense and you should be able to interpret them. Otherwise, if it was as easy as just dropping your data frame into a model, what's the reason for hiring you guys? So you're analysts and you need to analyze the numbers that you see. You should provide some reasoning, and maybe you do a cycle, so you need to back and forth for some reason. So if they just want some people to just drop tables into models, they can hire high school students. They don't need to have somebody with a master of business analytics. So first of all, the lower bound and upper bound it comes from formula, mathematical formula. And although sibling less than minus 1.1 doesn't make sense, but it could happen. For example, first quartile might be 1. Third quartiles might, let's say one number, let's say 1. So negative 1.5 times 1 is 1.5. Minus 1 would be minus 0.5. So yes, those values could be happen because it's out of mathematical formula. But lower bound of siblings less than 1.5 just means anything more than 0 sibling, or means any sibling is fine. Because 0 sibling is more than 1.5. 1 is more than 1.5. So anyway, it just means basically you don't have any lower bound. But any siblings more than 2.5, again, 2.5 sibling doesn't make sense, but this is just a threshold. Just means if you have siblings more than 3, 4, 5, these are outliers. So anyway, what I'm doing here, I already found my quantiles and the lower and upper bound for outliers, and I want to see which values are more than my upper bound or outliers, and which values less than my lower bound are my outliers. So basically, over my data frame, I'm selecting all the values. I'm looping over the columns. I'm just saying for each column, if their value is between lower bound and upper bound, return 0. Otherwise, return 1. Also, you might remember previously, I make some I use random function to create new column. With alias, you can make a new column, and the new column is just a previous column, because the C is the iterator over column names, plus underline out. For example, for age, every outlier are under age out column. So let's say this age of this guy is just 2. Look at age quantile. So anything, my lower bound is 2.5. 2 is less than 2.5. So it's the reason here I have 1. What about sibling? This guy has 3 siblings. So let's look at siblings. So upper bound is 2.5, and he has 3 siblings, so it's an outlier. And same for fair, parent children. So we make new columns, and in these new columns, if the observation of that associated column is outlier, we have value of 1. Otherwise, we have value of 0. Any questions so far? So it might be a new topic for you guys. I give you a couple of minutes to look over the previous blocks. If you have any questions, just ask me. Otherwise, after a couple of minutes, I continue the discussion. Okay, so now I have outliers of each numerical values. What can I do? I can again use a filter function and filter out everything that are not 0. So I'm creating a new column of outliers, which is summation of age out, sibling out, parent out, fade out. And let's see what happens. So with column, I create this column out of summation of the previous ones. So as you see, some of them are 1, means they are outlier in 1 variable. Some, like here, is 3. Because in age, sibling, and parent, these 3 variables is outlier, so the summation is 3 here. So easily, I can just focus on outlier columns and just use or filter the values that are 0. Means if here you have 0, means there is no outlier in any of numerical values. Also, after filtering out, I just don't need this out and outlier columns. These are extra, so I can just select these columns. What I did here, so here, I'm just saying that filter the one that are equal 0. I just want them. I just need this column. And now I do a descriptive statistics over my numerical columns again. So as you see, we don't have any minus. I still have age of 120 and 512. They're very different from our mean, but they are not considered as an outlier. Now let's look at the proportion of empty columns that I have. So look at here, I imported NumPy, and here I'm using mp.round because I want to return just a number showing me how many cells I dropped. The cells that I dropped means differences of my initial data minus remaining divided by initial, and I'm rounding with 4 digits. Although both of them has a function part and a digit part, but this one return a number, the previous round return a column. It might be a little challenging, I know. It's like you have similar names in different packages. So I lost 36% of my data. It might be huge, it may not. Maybe I drop very poor observations, and with the remaining, I can have a good model. If it's not, if at the end my prediction is bad, I should come back. Maybe instead of dropping outliers, I make dummy variables and I just regroup my observations based on their value. For example, instead of getting for age, for sure, minus something doesn't make sense. So that's fine. But maybe for fair, parch, and siblings, I'm basically instead of dropping outliers too expensive or too cheap, maybe I just make 2 groups and just say, or maybe I divide them 2 sections and make 2 different models. Anyway, it's the way that there's different ways that you can take care of it, but there's no guarantee which one is better. Okay, so let's do some visualizations. For visualization, you should call register temp table method on top of your Spark Sql data frame, and you just put an arbitrary name. And use display function and select all of the observation from that template. So whenever you use display, you might see 2 outcomes. Here, look at the left button. If I click it, you just see the values. If I click on this one, you see visualizations. If you select on plot, you can see there is different section. First of all, these are the fields that you use in you have in your table. Keys means the main group, as grouping is just a subgroup, and we have values. No worries, we go one by one. What I'm doing, I just said I have 2 groups over from my survived. 0 means not survived, 1 means survived. And I'm just saying that count, aggregation is count, all of the survived ones within each group, and display as a bar chart. Maybe I can change it to pie chart. Pie chart looks better actually. So 70% didn't survive and 30% survived. Based on this figure, what issue could possible to face?
Unbalanced label, right?
Yes, very good. So you have you want to predict survival of your passenger. When you have too many deaths and survive just even half of it, less than half of it, what happens? Maybe your sensitivity, which is for survival, is way less than your specificity, or basically you cannot predict these two groups equally. Maybe you predict the deaths or not survive much better than survive.
But
So
I think this percentage is good enough because in real world we always face maybe unbalanced label, maybe just 1% or 5%.
yeah, in real world, they are usually they are different, but what happens at the end? Maybe your sensitivity is much lower, lower than your specificity. So it might happen, it may not happen. I mean, we should check. But do you guys know how we can deal with the issue?
Yes, there are two ways.
Okay.
One is increase the label one, or two, and second is decrease.
Yes, very good. So you can do resampling.
Combine
Basically,
it together. We can combine it together. We can increase the label one or decrease the label one. Yeah,
yes, yes.
second.
Yeah, you are very good solutions. Actually, your friend is talking about resampling. So you might resample group one, make it more through a smooth, or do downsampling. Maybe randomly select 30% from group zero's death to make it equal to survive and look at the performance. So it might be different ways, but I mean, resampling might help you guys. So let's do something else. So let me just add 6 here. Now look at the figures. So I did a subgroup of 6. So as you see, 84% of men die and 60% survive. But for females, 72% survive, 28% die. So poor men. So again, for the figure, just play with the different, like you can count sum, mean, max, also different figures, QQ plot, scatter plot, bar chart. But anyway, at the end, you should interpret your result. Maybe you can just say, from this result, I can see my female are much more luckier in terms of survival, and male, there is a low portion of them survive. Also, maybe if you delete that, you can say your data set is not balanced. Maybe your sensitivity is much less than specificity. So these are the issues that might happen. So later, please play with these visualizations and you can find very cool things. So let's say the city. So for city, my main groups are city, and I'm looking at this number. I'm counting the survived cases, and that's what happened. So 61% are from Southampton. 12%, I think C was Cherbourg, I guess. Let's see. Yes, Cherbourg. So 10% London, 9% Queensland, 6% Delhi, maybe, no, 8% Delhi, 6% probably Beijing. So here, one of your independent variable has too many categories. So again, you cannot use categorical data in your model. You need to convert it to numerical values. You have two approaches. One approach, make label encoding, just randomly assign a number to them, or you can regroup your categories. let me just show in the bar chart maybe. Bar chart. So maybe what can you do? You say you merge Delhi and Beijing as Asian cities, one category Queensland, Cherbourg, and London, another one Southampton, or maybe one Southampton, and the second category just remaining. Anyway, when your independent variable has too many categories, if you do one hot encoding, maybe the variables won't be taken in the model. Maybe your model doesn't take it as an important variable. May or may not ruin your prediction, but anyway, you need to do multiple things. Maybe go back and forth. Maybe you do label encoding and it resolve it, or maybe you do one encoding, doesn't help. Maybe you regroup them. Maybe, as I said, if you use 6 dummy variables instead of 1, maybe you lose some information. It's better to merge some of them has low numbers to a larger category that makes sense. For example, Asian cities make sense, or maybe Southampton and remaining makes sense. So the way that you regroup them should make sense. Here, I just show another plot. Instead of making a subgroup, I just put city and sex together. It may not be a really good figure, but as you see, we have Southampton male, which is the most of your. And here I'm summing up the fare. I want to see the income or the money that paid by passenger, how it was distributed. So 47% of the fare value, again, here I use sum function, coming from males in the Southampton. 40% female from Southampton. 10% female in Queensland, and remaining. May not be very informative. I just want to show you what happens if you add 2 groups. Maybe you can just drop one of them here. Now you can look at the two subgroups, and in each you can look at the performance. I mean, distribution of your data. Again, this is a bar chart for each city. Most of them are Southampton. The other cities has a low appearance. So what you can, here I put an issue which already talked. So in the previous 3 blocks, we have issues. First of all, your dependent variable was not balanced. I said you can do resampling. Actually, one of your friends said, sorry. Also, some of your independent variables has too many categories. You can regroup them. For example, how do you regroup? Go back here. I just said whenever you see 888, change it to 9. If you want to regroup them, let's say instead of 888, you said whenever you see D, convert to Asia. Or whenever you see B, Beijing, convert to A. So what I'm doing here, I'm regrouping D and B with one group. So by the way, your next assignment is the questions that I put in this notebook. You may play with these blocks and change the figures, that's fine. But for your assignment, please download the original one from your model and answer these questions. So you need to provide some codes to show me how you resolve the issues. For example, how you did your resampling, how you take care of so many categories in your independent variables. As I said, one way is label encoding, another one, you regroup them to the smaller groups and do one hot encoding on top of them. And let's look at this figure. So based on this figure, so I did a bar chart. I count the value of gender, and I also regroup my groups are genders. So what issues might happen in my model? So here I might have a biased model. I have too many male, but female is very low. Maybe at the end, my prediction for the male passenger is much better than female. You might remember credit card issue that happened for Apple. So the prediction for male was much better for female. So I don't say for Apple credit card was the issue, but if you have too many observations in one group, few on other, you might have bias in terms of you might have a better prediction for one group than the other. Here, the approach, the solution is maybe you can go back the observation that you drop. So if you drop too much on female, maybe you do some countermeasure, not dropping too much, or you can do resampling. For example, you sample randomly select same number of observations from male and just focus on the balanced data set is one of the approaches. What about this figure? Please look at it, and can anyone tell me any issues here? Here is the bar charts of passenger in their classes. I give you 1 minute. It's very easy if you look at them. Do we have class of 2.5, 1.5, 3.3? Look at the data dictionary. We have first class, second, and third class. Here, we have class 2.5, 1.5, 3.3. So these are typos again. So what can you do? You either drop them or make them null and impute them with mode. As you see, visualization is a really important thing. Sometimes you might find a big problem. So class of 2.5, 1.5, 3.0 doesn't make sense. So how you can solve it is another question from your homework, and you should provide the code for me. So for your assignment, next assignment, just submit a Jupyter notebook that show me how you resolve the issue. Again, for this issue, you can either drop those observations, maybe you filter those names, or you drop them, you make them null and impute them. Since P class is a categorical variable, you can impute with mode. So for the plot one, as you see, I am looking at the P class, I'm counting them, is a bar chart. My groups are based on gender, subgroups basically. Groups are based on class, passenger class, subgroup based on sex, and I'm counting number of passengers in each group. For sure, there shouldn't be any 2.5, 1.5, or 3.3 passengers classes. Here, I want to show you another type of figure. So instead of making sex here to be a subgroup, let's see what happens if you put two groups. Now, I have group 3 male, 3 female, 1 female, 1 male, 2 female, 2 male. So what happens, the keys are created based on the value of both keys that you provide here. Is that recommended? I think it's better to have them as a subgroup. So it's much more easier to understand what is going on. Any questions?
No.
Okay. So please play with this Jupyter notebook, but at the end you might change the figure, so the question may not be applicable. So if you change too much, please download the initial or original Jupyter notebook and answer your homework based on the question that I provided here. I already gave you the solution on how to solve them, but it's not the only way. Maybe you find some creative way and answer these challenge issues by your creative way. Again, as you see, you can use it in your final project. Even in future, you don't do the project from scratch. Maybe you have some colleagues, you share a Jupyter notebook and just make it on top of that. So there is two ways for learning programming. One of them, reading the whole of the documentation and learn functions one by one. It's not a bad way, but I think the way that I recommend do hands-on experiences and build on top of the previous Jupyter notebook, because there is so many similar functions, different packages. Even if you learn one of them, other package might be the meaning might be different. So you can use some good Jupyter notebooks as your base work, and you may change them drastically. But whenever you find an issue, maybe you can Google it or look at the documentation and make those notebooks a better fit for your own project. So anyway, that's for today. So okay, please do the assignment. I already post them, and in case of any solution, you can just reach me. Hopefully from today, some university duties is less, so I'm much more faster from today to answer your emails. Anyway, thank you very much, and I hope you have a good rest of the day.
Thank you.
Thank you very much.